Good morning, math students. It's Miss Carol, and we are now on Unit 5. We're approaching the end of the course, and we have 4 lessons that have project questions within Unit 5. Those are 21, 23, 24, and 25. So for this video, I'll be covering Lesson 21, and there are 6 questions. They go as follows. A community high school has been exposed to the flu. As you may know, the flu is a virus that can spread rather quickly through a population and make many people sick. The principal wants to email parents and provide them with a graph that represents the spread of the illness. First, however, she needs to create the graph. So use your knowledge of the key features and graphs of exponential functions to answer these questions. Okay, so first question, there are 8 students initially affected with the flu. Each infected person is able to infect 5 new people per day, but only 2 of those infected people continue going to school and are able to infect others. So the function f of x equals a times b to the x plus k represents the number of people exposed after x days. So let's see if we can kind of plug some values in for that function to make it make sense for us. So one thing that we know right off the bat is that there are 8 people initially affected. Let me get my pen over here. All right, so our initial value when x is 0 is going to be 8. All right, so let's see if we can kind of work backwards on this. F at 0 equals a times b to the 0 power plus k, right? And we also know that this equals 8. All right, so anything to the 0 power, we should remember, is 1. All right, so now I know that f at 0 is going to be equal to a times 1, which is a, plus k, which is 8. Okay, so that is a really good first step. The next thing that I know is that 2 of the infected people are going to continue going to school to be able to infect others. So if I look at this function, all right, let's back up just a moment. Each person is able to infect 5 new people per day. So the part of our function, f of x equals a times b to the x plus k, the part of our function that involves the number of days is x, and the number of people per day affected is going to be our b value, which will be 5. Okay, so now we still need to figure out what a and k are, but 2 of those 5 are the ones who are going to continue to affect others. So that 2 is actually our a value. All right, so hopefully backing up there made a little bit more sense. So now that allows us to be able to find k. If I know that a is 2, then I can say that f at 0 is 8, right? Our initial value is 8. So 2 plus k equals 8. If I subtract 2 from both sides, I get k equals 6. All right, so this function is actually going to look like f at x equals 2 times 5 to the x power. That's what an exponential function looks like. It has x in the exponent, plus 6. Okay, I can't multiply the 2 by the 5 and get 10 because I'm only taking 5 to the x power. So we have to keep those separate. Okay, so let's see if I can scroll down and figure out the right answers here. So we did decide, they did tell us that the initial value was 8. We figured out that k was 6. And we also knew that a plus k, because 8 is our initial value, that a plus k equaled 8, okay? So those are the 3 check marks that you need here. Be very careful that you choose the right ones. Initial value is 8, k is 6, and a plus k equals 8. All right? Let's go down to the second question. Identify the y-intercept based on the information identified in question 1. Well, we know that our initial value is 8, and so our y-intercept happens at our initial value, okay? Our y-intercept happens when x equals 0, and we identified right here that when x is 0, our function is 8. And I can plug it in, go into a little bit more detail right here. Let's even plug it into this function. F at 0 equals 2 times 5 to the 0 power plus 6. 5 to the 0 power is 1. So F at 0 equals 2 times 1 plus 6 equals 8. So what we would want to type in here is our ordered pair. When x is 0, y is 8. Okay, those are the values that you'd want to type in right there. Okay, identify the horizontal asymptote based on the information identified in question 1. Okay, so what number will be, what number will y never ever be less than? Okay, so no matter what exponent that I choose for my x value, let's say I go less than 1, no matter what I choose for that exponent, my y value is never ever going to be less than a certain value. So if I chose, for example, let's say I made 5 a negative 1. Okay, I'm going to just rewrite this formula here. So if I have f of x equals 2 times 5 to the x plus 6, okay, so let's say I go negative with my exponent and I say f at negative 1, and this is negative time, so it's really not going to work for us, but it is negative time. So then I have 2 times 5 to the negative 1 plus 6, which is really 2 over 5 plus 6, okay? So then this becomes 6 2/5, right? The bigger my exponent is, so let's say f at negative 10, we'll do 5 to the third power, to the negative third, okay? Just because I can do that in my head, is 2 times 5 to the negative third plus 6. This becomes 2 over 5 to the third, which is 2 over 125 plus 6. What's happening here is that this fraction is getting smaller and smaller and smaller. 2/5 is bigger than 2 over 125. Okay, so this fraction is going to continue to get smaller and smaller and smaller, so that what I'm adding to 6 gets smaller and smaller and smaller, and what's happening is that I am approaching 6, and that is going to be my asymptote. So if I look at it from a graphing perspective, this function, I went ahead and typed in this function previously. This function, as my x values become negative, it's going to approach, it's going to get very, very, very close, never actually touching, but very, very close to 6, as you can see on this graph, okay? And then my exponent goes to 0, and I'm at 8, and then from there it just takes off in the positive direction. Okay, so let's go back. I think this might actually have answered a couple different questions. So we're approaching y equals 6 here. I think we demonstrated that pretty well. Each infected person is able to infect 5 new people per day. So we identified that the base of the function happens at 5, okay? So that's those 5 additional people are affected every day, so then they can go on and affect more people, and they can go on and affect more people, but that's why we added the 2 in front of it, because it's only 2 of those 5 people that are going to affect more people. Okay, so from all of the information you've gathered, describe step by step how the principal can graph this function to visualize the spread of the flu. So the first thing the principal should do is identify that horizontal asymptote at y equals 6. Okay, the second thing the principal should do is identify the initial value when x equals 0, y equals 8, okay? And from there, what I would do is plot points for x equal 1, x equal 2, x equal 3, maybe x equal 50, and then follow the curve for this increasing exponential graph. Okay? The other thing she could do is maybe just plug it into a graphing calculator, which you all have access to. The one that I used here is called MetaCalculator, and you can Google it. The equation that I used is right here. See how I plugged that in? I said y equals 2 times 5 to the x power plus 6. And then I just scrolled down, clicked on graph, and it generates this for me. And I think this provides a lot of information that I might not naturally intuit from a problem. Okay, so that is actually one more question. Based on your description of the function's graph, write a letter that the principal can send to parents to describe the situation and how they can help prevent the flu. So, you know, I definitely want to, I'm going to have you guys do this, but I want you to acknowledge to parents that the flu increases exponentially and the importance of keeping students home when they do have the flu. So I'm not going to type this for you. I think based on the information I've provided, you can get this one, but be sure to include that the spreading of the flu is an exponential function, and parents should take that into account in deciding whether or not to send their kids to school. Okay, thank you for listening today, and I will be back for lesson 23. There is no project questions, or there are no project questions for lesson 22, so I'll see you back for lesson 23. Thank you.